Sorry, I'm back. I pushed the stop button on accident. So, this distance from here to here is the square root of 13. The number that goes in the equation is r squared. So if r is root 13, then r squared is just 13. That is the equation of the circle. So if you have 2 points on the diameter, take the average of the x's, that's your h value. Take the average of the y's, that's your k value. And then use the Pythagorean theorem to figure out how long r is, and then plug everything into the equation. So circles are super easy. They're, well, at least this. They can get harder, but you won't have to do any of those. Okay, back here. 6. All right. So we have an f and we have a g. I want f plus g of 2. There are lots of ways to do this. I could figure out what f plus g is and simplify it and then plug in 2. Okay, that's the long way. The easier way is to just do f of 2 and add it to g of 2. And the same works with subtraction, multiplication, division, all of those. So I plug in 2, and on this one I get 1 over 2 squared is 4. 4 minus 9, I get 1/5, negative 1/5. And I plug in 2 there, and I get 0. So I'm going to add 0 to that, and the answer is negative 1 over 5. Okay, so those are easy. The harder one is the composition. What does that mean? That means we're going to plug 3 into g, and then whatever answer I get, I'm going to plug that into f. Okay? Or I could plug the g function inside the f function and then plug 3 into the answer. But it's probably easier to do it the other way. So 3 goes into g. 3 minus 2 is 1. Then I take the 1 and I plug it in there, and I get negative 1 over 8. Okay. Now, what about the domain? We've done this before. What is the domain of the composition? The domain is this. It's the domain of g intersected with the domain of this. And we ignore the domain of f. Okay? So when I plug g into f, I'm going to stick this in here. I get x minus 2 squared minus 9, which is x squared minus 4x plus 4 minus 9. Is everybody okay with that? So that's 1 over x squared minus 4x minus 5. Does that have any domain restrictions? X minus 5 and x plus 1. So x is not allowed to be 5 and 1. Negative 1. Thank you. Okay. So, does this have any domain restrictions? Does that have any domain restrictions? No. Okay. We don't worry about that, but we do need to look at the domain restrictions of this, which would be that, and in interval notation, x equals everything from negative infinity to negative 1, union with negative 1 to 5, union with 5 to infinity. Basically everything except negative 1 and 5. Okay, now the hardest part with this is just to remember what to look at, because you have three functions to deal with. You have this function and that function, but you only look at the domain of this one and the domain of that one. Okay, but what if the domain of this was x is greater than 4, and the domain of this was x is less than 10, and the domain of this was x is not allowed to be 7. What would my domain be? Well, I take the intersection of those. I can ignore this one. When I combine those, not combine them, when I intersect them, put what they have in common, what would the domain be in interval notation? From 4 up except 7. So 4 to 7, union with 7 to infinity. Does that make sense? Okay. All right. So we have a function. F is defined by those 5 points, and G is defined by those 5 points. Write out the ordered pairs of the function f times g. They're making you do that the hard way. Actually, this is actually easier. So, are they going to make you do 16 multiplications? So, here's what f does. Oh, that's not what I meant. This is f of x. So f of x takes -2 and attaches it to 2. Well, let's just do it this way. So this gets attached to that, and that gets attached to that, and so on. And then g also does some things. So it wants us to do f of x times g of x. So we want to know what happens when we take our answers in f of x and we multiply them to the answers of g of x. But that can only happen when f and g have the same domain. So are there any values where the f domain and the g domain are the same? So this number matches up with that one. And this one matches up with this one. And this one matches up with that one. So f takes -2 to 2, -1 to 4, and 6 to 10. And g takes those same numbers, -2 to 1, -1 to 4, and 6 to 0. And it's saying f of x is really the y value. Oh, did I mess up? Oh, thank you. So we want to take the answers of the f's and multiply them by the answers of the g's when the x's line up. Oh, hi. 2 times 1 is 2, 4 times 3 is 12, and 10 times 0 is 0. So the new function would be -2 to 2, -1 to 12, and 6 goes to 0. No, that's really easy. Now, why they're doing that, I have no idea. This boggles me. All right, do you guys understand that? Anyway. Yeah, why did I not use the other two numbers? The domains don't match. So if we wanted to do 0, I would do 0 comma what? Well, there's a 0 here, but there's no 0 on the other side. So I don't have anything to multiply it to. It's not like I multiply by 0. It is 6 times, there's no number to multiply it for, so there's no answer. So it just gets thrown away because 0 is not part of the function g. Okay, the other one's actually easier. Yeah, it's a lot easier. So f of g, that means we take some number x and we plug it into g, and then we take that answer and we plug it into f. So what am I allowed to plug into g? I'm only allowed to plug these numbers in. There are no other numbers. No, I have to plug numbers into g. What can I plug in? I can plug in -2, -1, -3, 6, and 4. Okay? And then I take the answers of g and I plug those into f. But some of them won't work because f is a very small function. So -2 gets turned into 1. Does 1 get turned into anything on the f side? No. There's no 1 in the domain of f. Okay, so we try the next one. -1 gets turned into 3, which then gets turned into 8. So if I skip the middleman, -1 got turned into 8. And that is the first piece of this new function. Okay, so this one didn't work. Now we try the next one. -3 gets turned into -2. Does -2 turn into anything in f? A 2. So we skip the middleman. -3 comma 2. Now, this does make a lot of sense. You actually do this a lot in mathematics. Okay. So both of those worked. 6 gets turned into 0. And then 0 gets turned back into 6. So skipping the middle, it's just going to be 6, 6. And then, so that one worked. 4 gets turned into 6. And then that gets turned into 10. So what does this function do? It goes straight from 4 to 10. Okay. Why would you use this? Well, let's say that you had a thermometer that was in Fahrenheit, and you had an equation that calculated how much water there is in the air, but that formula is done in Celsius. So if you needed to do a bunch of calculations, you'd have to take your temperature and convert it from Fahrenheit to Celsius, and then take your Celsius answer and plug it into the humidity formula, right? Well, if you combine the conversion formula and the humidity formula together using composition, that will allow you to plug your Fahrenheit temperatures, skip the Celsius calculations, and spit out your humidity value in the end. And sometimes there are 3 or 4 or 5 equations lined up. So instead of doing each one 5 times, we just crunch those all together, and then we plug in our x and we spit out the final y value that we end up needing. So this is really, really valuable. This, I don't know what they're doing there. All right. So here we plug 2 into h. So 3 times 4 minus 9. 12 minus 9 is 3. What do I do with that 3? Plug it into G. 12 minus 7 is 5. What do I do with 5? So the square root of 28, which is 2 root 7. How did I do that so fast? Does 28 have any perfect squares inside it? A 4. What's the square root of 4? 2. So 2 and then a 7 left over. Okay. How do we do this? We plug the f function into h. So we get 3 times the square root of x squared plus 3 squared minus 9. The square and the square root cancel. And I get 3 times x squared plus 3 minus 9. Do I want to simplify that? Yeah, I do. I should simplify it. So 3x squared plus 9 minus 9 is just 3x squared. Now I plug that into G. So 4 times 3x squared minus 7 is 12x squared minus 7. Okay, what does that function do? Well, if I put a 1 right here, then I would need to plug the 1 in there, take the answer and plug it in there, take the answer and plug it in there. Or I can skip all of that by taking the 1 and sticking it right inside that. See how that saves you a whole bunch of time? Oh, that's cruel. That is cruel. Okay, whatever. We'll do it. So what is the domain? So what do you think we do for the domain here? It's going to be the domain of f intersected with the domain of the entire function, skipping all of the functions in between. So I'll show you. It says all real numbers. Oh, how nice. Well, but you also have to look at the domain of f. So what did we end up with? We ended up with 12x squared minus 7. So we need to look at this domain and that domain, and we can skip all the others. Does f have any domain restrictions? The inside cannot be negative, but look closely. X squared plus 3. X squared is a positive number no matter what. And 3 is a positive number. So f has no domain restrictions. Right? And the composition is a parabola, and it has no domain restrictions. So in this case, all real numbers would be it. Now what if this said x cannot be 4, and this said x must be greater than 2, then we would say 2 to 4, union 4 to infinity. But you can skip the domains of G and H. They're not important. All right, one-to-one. Do you guys remember what one-to-one means? Means it passes the vertical line test because it's a function, and it passes the horizontal line test, which means it's invertible. So if it is one-to-one, then we can take the inverse, and the inverse is really quite easy. We have y equals 2 third root of 3x plus 5 minus 4. How do I invert a function? So we have a domain and a range. The inverse looks like this. I just turn every x into a y and every y into an x. So x is equal to 2 times the third root of 3y plus 5 minus 4. But in its current form, we can't graph it. So we need to solve for y. What do we move first? We start, so if we look at the y value, this is the first step, the second step, the third step, the fourth step, and the fifth step. And equations are like ogres. They have layers. And if we want to get to the center of this onion, we have to peel the layers off one at a time. So which layer goes first? This one. So we add 4. Then you divide by 2. How do you get rid of a third root? Cube it. And it might be better to do this. And then that becomes an 8. Now, subtract 5 and divide by 3. Okay, last one. Oh, there are more boxes. Thank you. Okay. The domain of f. Does this have any domain restrictions? It's a third root, not a square root. So no. So that domain would be all real numbers. Okay. The range of the inverse. Oh, sorry. Oh, that's the domain of f inverse. Okay. So the domain of f is all real numbers, which means that the range of f inverse is all real numbers. So this one is all real numbers. Okay. That now we look at the domain of f inverse. Does this have any domain restrictions? Do we have any square roots? No. Do we have any variables in the denominator? No. But I'm sure they're going to get harder than that. What if my function was the square root of x minus 4? Does that have any domain restrictions? Yes, x has to be greater than or equal to 4. That's the domain of f, which is the same as the range of f inverse. Okay? So when you invert this, you end up with, let's see, left 4. So it would look like this. Invert it. You get this. Does that have any domain restrictions? Yes. X has to, what's that? Oh, shoot. You're right. Sorry, forgot that. So, this is a bad example because that one's, they're not going to give you that. So to answer these questions, we look at the domain of f inverse. Ranges are hard to find. Domains are really easy. So once you have the inverse, look at the domain and of the inverse and answer that question. And to answer this question, you look at the domain of the original. Because in order to find the range, you'd have to graph it, and we don't want to do that. Especially because sometimes when you invert it, you end up with what looks like a non-function or a not one-to-one function, but it actually is. So can you guys remember that? Take the inverse, find the domain of the inverse. That's easy. To find the range of the inverse, look at the domain of the original function, and that's also easy. All right. Okay. How do we graph inverses? This one's easy. We draw a 45-degree line. You try to draw a 45-degree line. And then we reflect across that. So this point would get reflected to there. Right? But we know that an inverse is just a flip of the x's and y's. So 0, 8 is going to be graphed 8, 0. And 1, 5 is going to be 5, 1. And you'll notice that those are just reflections. But you don't need to reflect. All you have to do is flip the x and the y and then regraph. So number 10 will be a piece of cake. All right, get started today. I think there are only a couple that you're going to have questions on. Most of them are pretty easy. And when we are ready, we'll take the test.